Well, hello, everyone. I want to welcome you to our Lunch and Learn today. My name is Beth Graybaugh. I'm with Veterans in Agriculture, and today's program was made possible by the North Central Extension Risk Management Grant in USDA. If you have a question during the program, go ahead and put it in the chat, and at the end, Megan is going to be opening it up if you want to ask a question then. So today we're going to be joined by Hillary Olson. She is a soil health specialist with USDA's Natural Resource Conservation Service, or NRCS. So I'll let Hillary get started with today's presentation.
Thank you, Beth. As she mentioned, my name is Hillary Olson, and I am the State Soil Health Specialist for Iowa NRCS. I've been in this role for about 2 years now, and prior to that, I worked in the field offices across the state of Iowa for NRCS for a number of years. My husband and I farm in central Iowa, and I guess I was raised on a farm as well. So let's get started. Today, I'm going to be talking about the fundamentals of soil health. So I don't know about you, but it seems like whenever I pick up a farm magazine, or I look at people posting information on social media. I've even seen reports on the news, newspaper articles. It seems like soil health is everywhere. But when I look out my window here in central Iowa, sometimes I feel like soil health is nowhere. There are a few farmers around here that are trying some of these practices. But today we're going to dive into some of the fundamentals and some of the basics and explain some of the practices that pertain to soil health. So first we're going to talk about the soil functions. What are the things that we ask the soil to do for us? I've got 3 demonstrations that really illustrate how our management activities impact the functions of the soil. From there, we're going to go to talking about soil health principles and how our management and our practices impact those functions and what we can do with our management to try to incorporate more soil health to achieve greater soil functionality. And then finally, I will talk briefly about NRCS programs. So when I was a kid growing up, I really didn't think much about the soil. It was just something that you made mud pies in. You planted your crops in it, but nobody really thought a whole lot about what was going on underneath the surface. When I went to grad school at Iowa State and in soil science, I began to realize that there is a lot more going on underneath the surface than I had originally thought. And now since I've had this role, it's mind-boggling. All of the information that I'm learning, the new research that is happening. There is just a lot going on below the ground. So what are some things that we ask the soil to do for us? Well, first of all, we ask, we need it to provide food and feed for our livestock. It can also capture and store and filter our water. It can cycle nutrients. It can also help mitigate floods and droughts. And that really goes back to number 2. If we can get more water to infiltrate or to soak through the soil and to be stored in the soil, that means that we're going to have less flooding, that water is going to be available during periods of drought, and it also is going to help that soil weather the temperature extremes. Our soil also protects plants from pathogens and stress. It can store carbon. I'm sure you're probably aware that carbon markets are a real hot topic right now. We're going to talk really briefly about carbon today. And then also I've got those demonstrations are going to illustrate how soil and how we manage it can help that soil resist erosion. First, I'd like to cover the definition of soil health. So for NRCS, the definition is the continued capacity of the soil to function as a vital living ecosystem that sustains plants, animals, and humans. Now, when we first rolled out the concept of soil health, we referred to it as soil quality. But to me, quality means more, it makes me think of quantifying, measuring, and that sort of thing. But when we started talking about health, that makes me think of human health. The way that our diet and exercise plan, what we eat, how active we are really has a big role on our overall health. Well, the soil is similar. Our management plan, the diet and exercise plan for our soil, what we do for tillage, what we do for crop rotations, and the whole gamut really impacts the health of the soil. So if you look at those two pictures on the bottom, the one on the left looks like a cinder block. There's just a few roots that were strong enough to muscle through that compacted soil, versus the soil on the right. It looks nice and crumbly. A lot of times when we're talking about soil structure, we refer to things like cottage cheese, chocolate cake, grape nuts, whatever you want to think of. We want that nice crumbly structure. So you can see that those fine roots are all over the place in that soil. And it looks like if you applied any pressure at all, it would fall apart into some small micro aggregates. And there's also a lot of pore spaces in there. When I talk about pores, that's really just a fancy word for holes. But those pore spaces, that's where we can get the water to infiltrate. We can get the air exchange. And so I got a diagram here coming up to illustrate this, but just think about which of these two soils would be easier to grow a crop in. I think the obvious answer is the one on the right. So this is how, if we're managing our soils and it looks like that soil on the left where it's being compacted, this is where we see problems with the crusting on the top right photo. And when that surface seal is created, that means that it's harder for the water to soak in. And so that leads to things like the gully on the top left, and the bottom left photo, at the bottom of that gully, that sediment eventually will settle out and it creates a mess down below. And it also impacts the trafficability and how ponded our soil surface is. And so that directly impacts how we can farm. So soil health, whether you might like it or not, it really impacts your fields. This is in contrast with these four pictures. So something that I noticed about these pictures, they've got one thing in common. You can't really see the soil in any of them. There's a lot of cover on the top. There's terminated cover crops on the top two pictures. The bottom picture on the left, he's planting grain into that cover crop. And so this is going to protect that soil surface. It's going to protect it from erosion, from the pounding raindrops. And when we've got these sort of practices implemented, we can really increase organic matter and we can improve our soil structure, which is something I'm going to go into a lot of detail. So at the core of soil health is an aggregate. So this is a really important concept. An aggregate is sand, silt, and clay particles that are bound together with the help of organic matter, plant roots, and soil biology. So in this diagram, as I was speaking about earlier, we've got these big macropores, we've got smaller micropores. That really allows air exchange and water infiltration. We've also got over here on the left in the middle, it talks about fungal hyphae and bacterial colonies. So those microbes are really at the core of soil health. And so if we can think about our bacteria and fungi, they are the underground livestock. So if we can incorporate practices that are going to improve their habitat and their food sources, the soil health is going to flourish. As you can also see, there's microscopic water films in there, and that's where these bacteria and fungi and the microbes reside. So in this slide, I guess for me, in college, I always learned things and I remembered things better if I could relate it to something in my own life that I could relate to. So when we're talking about building good soil structure, I referred to the mineral components, the sand, silt, and clay particles. Those are the bricks of the soil. And so if you want to build a house, can you just go out and stack bricks together and call that a house? No, you can't. You really need something to glue it together. When we're building houses, we're talking about mortar. But when we're talking about building good soil structure, we're talking about things like biological glues, plant root exudates, and those fungal hyphae that are stretching through the soil. And the reason that this is so important is because, like us, these microbes live in those pore spaces, as I showed in that previous diagram. We live in the living rooms, the bedrooms, the hallways, the kitchens. That's where our microbes live as well. They live in those pore spaces. So if we can manage the soil in a way that allows those pore spaces to remain open, that's not only going to improve the habitat for our biology, but it's also going to allow additional space to store our water, our nutrients, and air. This next demonstration is a demo of aggregate stability. This is really an important concept of soil health. So the definition is the ability of the soil to withstand the pressure and forces of water. So you can't really see it in this video, but there's bubbles coming up in that water. These are these soil samples or aggregates are from the same soil type. These were from Southern Iowa. So the one on the left had no tillage for 20 years and they've had cover crops for about 10 years. This is in comparison to the field on the right where there's tillage in the fall and spring and there aren't any cover crops. And so what's going on here is that that water is rushing into those pore spaces. And that's why you're seeing those bubbles come out. As the water rushes in, it creates pressure within that aggregate. And if there isn't enough glue or mortar, those sand, silt, and clay particles blow apart, and that's what you're seeing. That's why it's so dark on that right-hand side. So those sand, silt, and clay particles are going to settle out. This is just on a tabletop. This isn't water rushing across the surface of a field. So as you can imagine, those sand, silt, and clay particles are going to move with the water down a slope, and they're going to settle out at the bottom. And that's what starts to create those surface crusts. So you might be wondering, well, what's the difference between this management? There's not any tillage and there's cover crops versus the management where they're doing tillage and they aren't doing cover crops. So let's talk about the two things that create aggregation. So as you can see, that aggregate from that particular field is completely gone. It's just melted. Those sand, silt, and clay particles are now in the water. That's going to impact our water quality. So it really has a lot of effects even beyond the field. So when I put that one back in, you can see there's a few aggregates falling off of that, micro aggregates falling off that larger aggregate, but they stayed together. So the two things that create aggregation are, number one, plant root exudates. So if you've ever dug a plant out of the ground and you hold it up and you look at the roots, there's usually soil sticking to it. Have you ever wondered why that is? Well, that's because through the process of photosynthesis, the plant is releasing exudates or carbohydrates out of its roots into the soil. And so it's doing that because it wants to attract the microbes in the soil to come towards the plant root. So that I like to think that plant root zone is kind of like a buffet table for our microbes. So all of these bacteria and the fungi, they're moving through the soil to get to that plant root zone. And so they live there and then they will eat each other, they'll die, they'll poop. And so when that happens, that's releasing nutrients because those microbes have enzymes that allow them to break down the nutrients into a plant usable form. And so it's a win-win situation. The plant is using a lot of its energy to create these plant root exudates. And in exchange, the microbes that's their primary food source. So they're getting something out of it. And then they're releasing the nutrients that the plant needs. The second thing that creates plant root or aggregation is our biotic glues. So this picture on the left is an earthworm channel. Have you ever wondered why those earthworm channels remain open even after the earthworm is gone? Well, if you've picked up an earthworm, which I'm assuming you probably have, those earthworms are slimy. And so as they go through the soil, they are cementing those sand, silt, and clay particles together with that slime. And so that's essentially creating an elevator channel for those earthworms. And so that allows them to go up to the surface, they can get residue and pull it down into their hole. They don't have to use more energy to create that hole again. So that is one of the primary components of our biotic glues. This picture on the right is a mycorrhizal fungi picture. You can see that it's got some droplets on it too, so they're sticky as well. Those fungi stretch out through the soil kind of like house trusses. And so you can imagine if you came through with a piece of tillage equipment or a rototiller, if you have a garden, if you came through with that implement, it's going to slice and dice that long organism there. But all of our bacteria and fungi, I want you to remember this, are all sticky. They've got this, this biotic glue. And so as they move through that soil, they are cementing those sand, silt, and clay particles together. So now we have our second demonstration, and this is an infiltration test. So what I've got here, this the soil on the right is actually from my home farm in central Iowa. The soil on the left is from also a soil or a field here in central Iowa where they've been incorporating no-till and cover crops. I've been working on my family to incorporate some of these practices, but you know how it is when you work with your family. So as you can see, the sample on the left, can you see how it's dripping through there already? So that means the water is already infiltrating through that soil profile, as opposed to the soil on the right, where you can see that it's starting to pond up on the surface. This made me really nervous last year when we were in that drought. And so I knew that our practices were creating that surface seal because those, as that slate test showed, those sand, silt, and clay particles blew apart, they settled out on the surface, and that's what creates that surface seal. And that's why you have more runoff on the surface, because that water simply can't get into the soil profile. Why is this important? Well, here's a real life example of an infiltration test. This was taken in Northeast Iowa. There's a fence row right down the middle. So on the left, you can see that there are standing corn stalks, so that producer is not doing tillage, compared to the field on the right where it's a lot of bare soil, so they're doing tillage. They both got beans planted, but you can see that there's a lot of standing water in between the rows on that field on the right. So this really impacts trafficability, field operations. So the producer on the left, you can see that his weeds are starting to look crispy. So he was able to get in there and spray a lot sooner than this producer on the right. His weeds are still looking, they're still doing great. And so he hasn't been able to get out there to spray. So this is how soil health really can impact our overall farm operations. Here's a diagram. So you can see those aggregates, those spheres there. There's those pore spaces that are remaining open because there's enough glue to hold those aggregates together. And that allows that water to infiltrate, versus the field on the right, where those sand, silt, and clay particles, they blew apart, they melted, like in that slate example, and they settled out on the surface, and that's what creates that crust, and that's why you get ponding and you get runoff. The next demo is a rainfall simulator. This is our desktop version. So we have trailers that we'll haul around for a larger tray, but so I'm pouring the same amount of water. This is the same two soils. So the field on the left is from my home field with the tillage, and we don't have any cover crops, but look how fast that water's coming off. And I also want you to look at the difference in the clarity of the water. Look how clear that stuff on the left is. So that was a heck of a rainstorm. That was a lot of water coming at that soil surface in a short amount of time. but just look at the differences. I got those two samples the exact same way. I pounded those trays in and I dug it out. Look at the difference in the water. And then also look at the infiltration here. So this is showing you the conventional. There's not a whole lot of infiltration there versus this field over here that was no-till cover crops. You can see that there's a lot more water infiltrating through that soil. And so when we have those pore spaces in that field that are left open, it could really absorb and hold more water, especially if we can start to improve our organic matter. So at the core of this soil health puzzle is the good structure, and that's what I've been hammering on the last few minutes. So if we have good structure, if we have that pore space, we can get the water to infiltrate. We've seen that in these previous demos. If we are building the home for our microbes, we're going to have a lot greater soil biodiversity. If we've got greater biodiversity of our underground livestock, of our microbes, each of them has a unique niche. They have different enzymes. They can break down different nutrients. And so if you have a diverse ecosystem down there, you're going to be cycling your nutrients a lot more efficiently. And if all of that stuff is falling into place, the overall result is increased resiliency. And that's really what we all want from our fields and our soils. I'm going to spend the next few minutes talking about soil carbon. The carbon markets have been a hot topic here of late, and I just want to emphasize how important soil carbon is. Whether you decide to join a market or not, soil carbon is really at the core of soil health. So let's just do a little background information here. You might hear the term carbon sequestration. What is that? Well, that's simply when the plants take carbon dioxide from the air and water from the soil, and they use that to build those carbohydrates. And that was the plant root exudates that I spoke about earlier. And so those are feeding the organisms, and then organisms are respiring and they're releasing that carbon dioxide back into the atmosphere. They incorporate some carbon into their bodies, and those plant roots pump carbon into the soil. So it's a cycle. But in the end, what we're hoping for with our management practices is that we want to store more carbon in the soil than we're releasing. That's the end game. So next, we're going to talk about some different ways that carbon can get into the soil. We can either have decomposing plant matter, like this picture on the left. Those root exudates are a good source of carbon, and then the soil organisms through their bodies themselves. Carbon can be found in different states in the soil, dissolved in the water, in large chunks or particulates, and also it can be enveloped into those soil particles, those aggregates that I was showing you. So if we are doing tillage, we're going to break those aggregates apart. And so when that happens, you're exposing that carbon to air, you're pumping a lot of air into the system, and those microbes go nuts. It's kind of like if you have any high school football players, when they come home from practice, they're starving, they are going to go through your fridge and eat you out of house and home. It's the same thing with our microbes. Once they get that flush of air, they're going to go nuts. They're going to have a spike of activity. And so they are going to eat each other. They're going to eat the organic matter. And so that's when we start to lose our carbon, our organic matter, through that act of tillage. And so if you can do no-till, that helps protect that carbon within those aggregates that are stuck in between the soil particles. The next couple of slides are going to drive home the importance of cover crops. So if you've seen a solar field, you know that you got to have those panels in order to harvest that solar energy. And so that's what's going to be converted to electrical energy. Likewise, the leaves of our cover crops, you can think of those as solar panels. And so they are collecting that sunlight and they are pumping that energy and that carbon back into the soil. So without cover crops or without a green living plant, you aren't getting that benefit. So here in Iowa, our primary cash crops are corn and beans, and they're growing usually, April to October. And so you have another 6 months out of the year where nothing is growing. And so that's where these cover crops can really fill the void. to provide more food to our microbes, to keep those communities moving. And it really provides a multitude of effects or benefits that we're going to talk about here. If we can start to reduce tillage, if you can reduce tillage or maybe reduce the intensity of your tillage, that's a start in the right direction. If you can start trying to incorporate cover crops into your system, that's going to pump more carbon into the system. So by eliminating some tillage, you're reducing the loss. By incorporating more living roots into your system, you're going to increase the energy. And so that's what really drives the system. So here are the 5 soil health principles. In Iowa, we decided, so there are 5 in Iowa. I'm going to show you in some other areas, they've consolidated it down to 4, but we felt that integrating livestock was important. So the first principle is minimizing disturbance. I've got future slides that are going to illustrate the differences there or the impact with that. I'll just quickly go over these. So maximizing cover, maximizing biodiversity, having that continuous living root throughout the year, and then integrating livestock. Those are the 5 soil health principles. So in this diagram, they've consolidated it down to 4 principles. They put the livestock into this maximizing biodiversity principle. So we're going to talk about the ones on the right here, these 2 principles, minimizing disturbance and maximizing soil cover first. Those are going to protect our aggregates versus the 2 principles on the left, maximizing roots and biodiversity. Those are going to feed our microbes. So minimizing disturbance, that can help. If we can minimize disturbance, we can create more habitat for our soil organisms. So when you do tillage, as I mentioned earlier, it destroys those mycorrhizal fungi, it destroys those pore spaces. And so the soil organisms don't have a home once you've done that, and it destroys the soil structure. Some common types of disturbance in our agriculture systems are physical through the tillage. Chemical disturbance can happen through over-fertilization, using a lot of pesticides and some soil amendments. It can also be biological. If we're talking about grazing systems, it could be overgrazing. It could be a fallow system if you don't have anything growing out there at all. It's hard on the soil. And then monoculture plant systems. So what practices can minimize disturbance? If we can start to reduce our tillage, if you could start no-tilling and strip-tilling, that's an excellent way to start reducing your disturbance. And you can also incorporate conservation cover. This would be seeding natives, introduced grasses, mostly natives and pollinator habitat is what we think of in NRCS. To create those communities of beneficial organisms. It would also help protect the soil. Nutrient management, if you can more efficiently and effectively apply your nutrients to the amounts that you need, that's a great step in the right direction. Integrated pest management, we need to be thinking about making sure that you're doing scouting before you apply your fungicides and your pesticides to make sure that it's going to be effective. All of these things are good tools in the toolbox. As I mentioned earlier, we farm, and so I want to be able to use those tools. I want them to remain effective. So if we can use them judiciously, that means they'll be more effective when we need them. There's also prescribed grazing is a big way that we can minimize disturbance, because if you are continuously grazing the same plant, it can't recover. The root system suffers, and there's a lot of bare soil in some of these continuously grazed systems. Next, we're going to talk about the way that we can maximize soil cover. We talked about minimizing disturbance. So next, we're going to talk about all the benefits of maximizing soil cover. This thermometer shows soil temperature. So if we can protect that soil with a cover, it's really kind of like the roof for our microbes. I was on my parents' field here in central Iowa a few years ago. It was a 90-degree day in June. There wasn't much for surface cover. That soil temperature was 130 degrees. So you can see at 130 over here, 100% of that moisture is lost through evaporation and transpiration. It also means that the bacteria and the fungi were dying and that they weren't able to function. So something I've noticed is my travels across the state, when I am comparing soils that have cover crops or crops growing, it's usually about a 20-degree difference. It's cooler under those cover crops, under that residue, as opposed to bare exposed soil. And that can make a big difference, especially when we're in a drought situation and you need to hold on to every drop of water that you have for your plant growth. So that is, some of the importance of maintaining that cover. It can also help you suppress weeds by limiting the sunlight, and it also provides a food source for our microbes. So this summarizes some of the things that we just talked about. On the bottom here are similar pictures to the one that I showed earlier, where you have that surface ponding. When you don't have that surface cover to protect those aggregates, they really start to blow apart, like in that slake test, and will settle out and create that surface seal. So cover is a really important soil health principle. So what are some practices that we can do to maximize soil cover? We could implement cover crops. We could look at reducing our tillage. Again, there's conservation cover if we seed more natives and introduce grasses. Mulching, that really comes into play in some of our large garden situations. Controlled traffic, if we can stay on the same path, especially with our grain carts and semis in the field in the fall during harvest, that can help with our cover. Pasture and hayland planting and prescribed grazing. So NRCS does have cost share opportunities available. I'm going to talk about later. If you've got a crop field and you'd like to try grazing, we can help you with seeding and a lot of the different grazing practices. But those two things are definitely ways that we can help maximize soil cover in pasture situations. Now we're going to switch gears and talk about the two soil health principles that feed our underground livestock. By maximizing our living roots, having that root growing out there all year long versus maybe just 6 months here in Iowa, and then maximizing the biodiversity. If we can incorporate a diverse cover crop mix, if you could add another crop into your rotation, all of those things are going to provide the benefits here on the right. It can help break your pest cycles. It can increase your predator populations, which can help with your pest management, improve your nutrient cycling, soil organic matter. So how do we do that? How do we maximize living roots? Well, if you can grow those crops in the off season, that is huge. I mean, that can really help your soil turn the corner if you're trying to implement soil health. Avoiding fallow situations where the ground's bare. Increase your time in perennial crops. I would love to see a viable third crop being grown more in Iowa. I know that people are trying it. I know market availability can be a challenge, but that would be a good way to maximize those living roots. And then again, when we're talking about pasture situations, if we can rotate our livestock in a way so that it's giving paddocks a break, it can allow those plants to recover so that they can have more leaf area to collect that sunlight, as I was speaking about earlier. They can pump more of that energy into the soil and to their roots, and that really will pay dividends for you in your grazing situations. So again, we've really covered some of these practices. A lot of them are the same for these principles, incorporating more crops in your rotation, having that the cover crops, and the way you manage your pastures is really going to maximize your living roots. How do we maximize biodiversity? We can grow diverse cover crops and legumes. We could implement more crops into our rotations. We can also integrate livestock. I love to see livestock out there grazing on corn stalks and growing cover crops. If you're looking for microbial activity, the first place I go to is a cow patty, because if you flip that thing over, there's all kinds of critters under there. It's like the fast food stop for microbes. The livestock are really they're cycling that the food sources that they're eating, and so they're processing it in their gut, and it's available for immediate use from our microbes out the back end. So if you can get livestock incorporated into your systems, that is really key for speeding things up. So we're looking at some of the same practices here again with rotations and covers and our nutrient and pest management here, and our grazing practices. So now I'd like to talk a little bit about changing your system. If these are practices that you would like to try adopting on your farm, there's some things to consider. So I said I grew up on a farm. So my brother and my dad are actually trying to incorporate some no-till and cover crops on their fields. And so it's been really interesting. They're within the first year or two. And so it's been a lot of fun to go out in the field and to watch them start their soil health journey, and to see for myself what all goes into getting started. So some of the things that you'll need if you're thinking about transitioning is that you really got to do a lot of homework. The way that you've been used to managing things is going to change, especially if you're incorporating cover crops. You need to think about what your goals are, what cover crop species you want to start with, how you're going to get those terminated. You need to have a backup plan in case your termination plan doesn't go as planned. You need to think about your equipment. So it's not that you need to go out and buy new equipment. We have a 30-year-old planter that we are incorporating some different tools into. You really got to focus on your planter and make sure that all of the equipment is working like it should. Just last week, we were digging in a field that we were trying no-till on, and in the rows that the combine didn't do such a great job distributing that residue last fall, the corn wasn't going in deep enough. And so troubleshooting through that, the planter, and trying to figure out that issue. We got it figured out, but that's something that you would need to consider. Also, I get this question a lot. Well, how long is it going to take from when I start to when I'm going to see all these benefits? It will take some time. I think of it kind of like weight gain and weight loss. You probably didn't get to the weight that you are overnight. Likewise, you can't lose that weight overnight, unfortunately. So our soils are the same. It's going to take some time to see some of these benefits. Now, I do have the opportunity to travel across the state. And one thing that I hear consistently from farmers in every area is that the first thing they notice is that their fields infiltrate water better than they did before. So that's something that I think that you would see a faster benefit than maybe improving your organic matter levels per se. Also, I think support is huge. So with my brother, this picture here on the right is a producer that I worked with in Polk County. So he started his journey by splitting his fields in half. He did cover crops and no-till on half of his field and did conventional farming on the other half, and watched to see what happened. So you can see from his license plate cover that he's a believer now. And so I have got my brother into contact with this farmer so that they can chat about things that they're seeing. If they're running into problems, that really helps to have that support system, to have people to rely on. This is a summary slide of what we discussed. So it's really important to plan ahead, have your support team Start small. That's the best way to do it. You don't want to, hang yourself out to dry. I want people to be successful. So start small and figure it out and then scale up. You need to understand that your management will change, especially if you're adding some cover crops. The patience doesn't happen overnight, and continuing to learn. I will say that I've heard multiple times that farmers say that farming is fun again now when they've implemented these systems. And I think it's because they enjoy the challenge. So I'm going to switch gears here a little bit and talk about the conservation planning process. So this could be used if you're thinking about transitioning, or even if you're not thinking about transitioning. This is a tool that NRCS and Soil and Water Conservation Society or districts offer free of charge. You can call the field offices, and I'm going to provide some contact information here at the end. You can call them, you can talk about your goals. They'll come out and do a field visit, analyze your resources, provide you with some options. You can decide, in conjunction with family members, tenants, landowners, you can decide what you want to do and when. And then we do have programs available should you choose to go down that route. But this is a picture of a conservation plan on the right. And here's an example. So we had some landlords that were really concerned about water quality issues. This is when, Des Moines Water Works lawsuit was going on, and they lived out in New York State and Washington State, but they had caught wind of this. And so they were concerned about water quality. And so what they really wanted to do was to implement a wetland. And so they contacted the office. We analyzed the watershed. It was such a big watershed that it was going to be over 20 acres in size, and it was going to impact the neighbor. The neighbor wasn't willing or wasn't interested in incorporating that practice. So we went to Plan B, which is a bioreactor. That's the picture in the middle. That's just a pit that's excavated. It's lined with plastic. You've got wood chips in there. You divert the tile water through that those wood chips, and the wood chips react with the nitrates in the water and remove them, and the water flows back out into your tile line. So we looked at a bioreactor in that situation. Unfortunately, the tile was too big and too shallow to incorporate a bioreactor in that field. So then the third option was trying to incorporate cover crops, which also do a great job of removing nitrates from the water. And so that's just an example of the series of things or questions that you might go through if you'd like to work on a conservation plan. And so this could be, it doesn't have to be water quality. We have all kinds of resource concerns, erosion, air quality. If you've got pasture, we've got grazing resource concerns. So we really have, I guess, a lot of different practices that can fit your needs. These are some of the common practices that we see in Iowa. Management practices on the left, we see a lot of reduced tillage, cover crops, incorporating a different crop into your rotation, the nutrient and pest management, and incorporating conservation cover. Some of the structural practices include terraces, waterways, bioreactors, water and sediment control structures, and constructed wetlands. I just want to cover some basic program guidelines. You have to have an approved contract before you start a practice. When I was in the field office, I would get calls in December from somebody that had seeded cover crops that fall. And I always hated to tell them, that's great. Thank you so much for doing your part. But unfortunately, I can't help you with cost share because you've already implemented that practice. We didn't have money set aside for you. We're not sure if what you did followed our specs and standards. So I wasn't able to help in those situations. So if this is something that you're considering doing, make sure that you're contacting the office well in advance, 6 months to a year, because some of our programs have deadlines. And so you might miss that deadline and have to wait for the next year funding. Another thing that there was some confusion on sometimes is that when you submit an application for a cost share program, that does not mean that you will get funded. Unfortunately, there's not enough money to cover everybody. And so you're not guaranteed that you will get funded. And so that's something I just wanted to emphasize. Eligible practices may vary by the location. In Iowa, we have a lot of the same practices, but if you're connecting from another state, I would encourage you to reach out to your field office to see what practices are available for you. Something else I'd like to point out is that these assistance programs are voluntary, they're not mandatory, and that as USDA employees and SWCD employees, we're not allowed to promote any programs or services from outside entities. If you go into a USDA service center, there's going to be multiple agencies and staff in that office most times. So the Farm Service Agency, they help administer a lot of farm bill programs. They keep track of the land ownership. They give you things like the farm number, the tract number, which is important for NRCS staff. That's something that I wouldn't stress out about. But start with a Farm Service Agency because they will help make sure that you've got all of your eligibility done. I've got a slide coming up here to talk about that. But they handle those things. And then the NRCS handles the technical service. We have some standards and specs. And so we do a lot of the field work. We will meet with you out in the field and talk about your resource concerns and explain some of the technical things of those practices. We also have Soil and Water Conservation District staff, which is usually housed with the NRCS staff. From the outside looking in, you probably aren't going to be able to tell a difference. We work together on all the same projects for the most part and practices. And so there's a really strong partnership in Iowa between those two groups. So there are federal and state financial assistance programs available in Iowa. I'm not going to go very deep into these. This could be a whole nother session, but for the federal options, we've got the Environmental Quality Incentives Program. That's really where you're looking at a particular practice or suite of practices. You implement the practice. We come out and check to make sure that met our specs, and then if that's the case, which usually oftentimes it is, then we pay you, contract's done, and everybody moves on with life. Conservation Stewardship Program is a little bit different. It's a 5-year contract where it's really geared towards people that are already implementing some practices on their farm, but they want to take it to the next level. And so that's a little bit different of a program. We also have the Conservation Reserve Program, which we work with Farm Service Agency to seed fields down for a 10 to 15 year time span. The state financial assistance programs include Financial Incentives Program. That includes structural things like waterways, terraces, and basins, and also the management practices like cover crops and no-till. They've also incorporated the Water Quality Incentives Program. And so that really targets practices that are going to help with water quality, such as cover crops, reducing tillage, and the nitrogen inhibitors. I also want to bring to your attention that in Iowa and in a lot of the other surrounding states, we're starting to see this cover crop insurance premium reduction. If you're incorporating cover crops and you didn't get paid through a cost share program, you're eligible if you apply for this $5 discount. And so I've got the link included there below. So that's another benefit. So applying for these conservation programs, they're really geared to help reduce the risk during that learning curve, especially if you're starting to change your management system. There's a lot of things to figure out during those first couple of years. And so that can help reduce some of the risk. We will help you develop a conservation plan. We'll take your goals in mind, talk to you about the practices and the implementation schedule. And then that's where you develop that conservation plan. Our applications are taken continuously throughout the year, but we do have those cutoff dates that I mentioned earlier. So again, if you're thinking about trying some of these practices, I really encourage you to reach out as soon as possible. We rank the applications for most programs, especially the federal programs. They're based on the environmental benefits, the resource concerns that you're addressing, and the cost effectiveness of the proposal. To get started with NRCS and the soil and water conservation districts, you need to first reach out to them, go through that planning process to determine your resource concerns, your practices that you want to implement, and when you'd like to start. Then we'll help you figure out which cost share program best fits your needs. I always try to take each unique situation in mind to figure out which program would fit the best. One thing I want to make you aware of is if you are doing the same practice, so let's say you're seeding a field to cover crops. I can't pay you for cover crops with EQIP, with CSP, with state cost share on that same field for that same year for the same cover crop. We can't double dip. So that's something to be aware of. To get started with USDA, as I said, if you're not already in the system, please start with a farm service agency to complete that basic paperwork. If you're not in the system, heads up, you will need to provide a deed, and they'll look at things such as the adjusted gross income and other basic eligibility requirements, but they'll walk you through all of that information. Over here on the right, I have the link to find your local service center. I've got it here on the next slide as well. I would recommend just Googling USDA Service Center. That link is there again, but just Google that and it will help you locate by state and by county your local field office. So in summary, with the, from the field office perspective, financial assistance side, it really starts with the conservation planning process. We have a ton of practices and programs, multiple programs available. So please just reach out to us. There's the 5 steps to assistance down there at the bottom. You start with planning, then you apply when you know that you want to implement those practices. We go through eligibility and ranking, and then you can implement those practices. So this has been a lot of information over a short amount of time. I really hammered on soil health and how really that's at the core. If we can increase our aggregate stability through our practices, if we can have more biotic glues and really cementing those particles together, we're going to have better infiltration. When we have better infiltration, it's going to reduce runoff and help alleviate some of our water quality concerns. And it's going to help your soils and your fields function better. So with that, I will hand this back over to Beth.
Well, thank you, Hillary. That was a lot of really great information. You covered a lot of ground, and I could tell you're passionate about this subject. I really like your term underground livestock. I never thought about microbials and such being referred to in that manner, so I love that term. And I guess to follow up, I always make sure encourage everybody to become familiar with their local USDA offices, because they really need to start there. There's so much information once you get connected with them, making sure you have that farm number. If you don't, as Hillary said, take in that deed, and that will show that local office what land you own, and so that you can get that farm number process started. And then that will also get you access to newsletters, so when these sign up dates are occurring. And then I also wanted to remind everybody, for the veterans in the group, that there is sometimes with your cost share rates, you can sometimes get a little extra bump in the amount of cost share that you can earn over someone that has not served. So important that when you're in those USDA offices that you're letting them know that you're a veteran, because there are benefits that you will get for that service. I usually say you worked for the company. USDA is part of the same company that the military is, so you need to be aware of some of those benefits at USDA. So does anybody have any questions? Again, I want to thank Hillary for the great presentation she provided.
And I'd like to point out, if anybody is interested in incorporating some of these practices, or even just having a conversation, you got more questions, don't hesitate to reach out to me. We have other area soil health specialists working for NRCS in the different areas of the state. So they'd be happy to have a discussion with you as well.
Okay, we don't have any questions. I want to again thank Hillary for her time and all of the information that she provided today. And like I said, great information on this very big subject. You were able to condense it down for us. So I appreciate that very much. And I appreciate everybody that was able to attend today.
Thank you for your time, everybody.
All right, thank you.